Guys, we're looking at another problem on arc length for matrix 6. So this one says calculate the length of the curve x equal to y to the power 4 by 8 plus 1 over 4y squared, where 1 is less than or equal to y less than or equal to 2. So in this case, again, as we always know for arc length, the limit should be the key thing that we must pick out. So if your limits are in terms of y, then the formula you are copying for arc length on page 7 of matrix 6 must end with dy. If they're in terms of x, then your formula ends with dx. So what I'll simply do is go to page 7 of my formula sheet. I will look for that formula that starts with s. S is representing the arc length and ends with dy. So that formula is the integral from c to d, the square root of 1 plus dx over dy, or the square dy. So that is it. So the question on arc length, please just make sure you get the right formula, because with the wrong formula, you're already out of this question. So our formula ends with dy because the limits are same. So here we're looking at our equations. Equation is already making x the subject. So we'll go on and look for dx dy. So if I'm looking for dx dy, sorry, before we go there, I can see some little problem. Our formula, they've made x the subject, but you see y is at the denominator. That is not possible to integrate, to differentiate, sorry. So the first thing is that I will try to rearrange that to be y to the power 4 over 8 plus y to the power negative 2 over 4. We can't differentiate x at the denominator, so we have to take it out first to permit us to do our derivative. So now looking at the equation in this manner, I can now look for dx over dy. So dx over dy means I go through the problem, every y I see, I differentiate it. So if I do that, the first term will give me 4y to the power 3 over 8 plus the next term will give me negative 2y to the power negative 3. Remember, with derivative, you take the power in front, then you subtract 1, then you divide by 4. So that is what we get. So if I simplify this, this will give me y to the power 3 on 2. Then this will now change to negative because of negative 2 on negative 4. So that becomes negative 1 divided by 2, because 2 will simplify that, y cubed. Remember, when you are done with your derivative, don't forget to make sure that your powers stay positive. So that's how this second term is reduced into that, because y to the power negative 3 will go down as y cubed, then 2 will simplify 4 to give me 2, then that negative comes there. So in that case, I'm done with my derivative. That means, according to the formula, I'm done with this portion. Then the next part is the square. So I have to square my derivative. So dx over dy, all that square means I'm writing y cubed over 2 minus 1 and 2y cubed, all that square. So there is a small technique I've always shown my students on expanding something like this to the power 2, which I believe you must have practiced it well by now. So when I look at that problem, what I'm seeing is a minus b, all that square. So I expect 3 terms. So how do I get my 3 terms? I take a, I square it. That's how fast I can do it. If you take negative b and square it, it will change to positive. Each time a negative number sees a square, it becomes positive. Then in the middle, I will simply take the power times the first times the second term. And please be careful, apply this technique only when you are sure that the power is a 2. Don't see a different power, then you start trying to impose that to it. So if I expand this, that is how I see my 3 terms. So I will try to take us through that. This is your A, that is your B, that's your 2. So if I'm expanding that, I need to see my 3 terms. So I'll take the first term and square it. If you square y to the power 3, it becomes y to the power 6 over 4. That's my first term. Then if I go to the last one, I will be getting 1 on if I square this, it's like I'm doing the square of b, I'll be getting 1 over 4 y to the power 6 also. Then in the middle, I'll be taking 2 to the power times the first times the second. If you look at it and it looks like it's too complicated for you, you can do it gently. The middle term says you take 2ab, that's my a, that's my b. So I'll take 2, my a is y cubed over 2, my b is negative, don't forget that b has a negative, 1 on 2y cubed. So that's what you see. So in this, you see that this 2 will simplify with that, y cubed will simplify with that, you're only left with negative 1 over 2. So with that your expansion, you get negative 1 over 2. And then you put your plus positive sign. So that is what you see from that expansion. So if I'm done with that expansion, the next thing is I will take 1 plus that square. So if I go to that, I'll get 1 plus dx over dy, all that square. That means I'm taking 1 plus this answer up here. So this is y to the power 6 over 4 minus a half plus 1 on 4 y to the power 6. And if you now look at what we've got, you see that the first term and the third term are like terms, so we can pull them together. You get 1 minus a half, that becomes y to the power 6 on 4 plus a half. 1 minus a half is a half, then plus 1 on 4y to the power 6. So that is how you have managed to simplify what is at the under the square root. But at this stage, you need to really think out of the box to know how to come out of this, because whatever you're transferring under the square root should be something that the square root should manage, or it should be reduced to 2 terms so that you can check for the formula in your formula sheet to sort that out for you. But looking at this with 3 terms, this is a challenge. But if you are smart enough, you will figure out how to come out of it by first of all doing some comparison. If you check what you've done up here and you check what you've written down here, you see that there is a close resemblance between the two of them. The only difference is that this is positive a half, that is minus a half. But looking at it, you see that you know where this is coming from. It is from here that we got this. When you expanded this, you get that. So if this is also close to that, it means this will also be coming from there with a sign that is opposite to that one. So if you can be smart to think like that out of the box, it will be easy for you to see how to simplify this to get up there, which is something that it's not easy to see, but if you can compare these two, as I've explained, you see the difference is just the middle term, and you know exactly where this is coming from. So this one must also come from there. So this and this are like twins, and knowing that twins have the same mother, then it's obvious to pick it out that if you were to simplify this one to factorize it, you will get y cubed over 2. You see I'm looking at the answer of that one. Then instead of a negative sign, I will put my positive sign into 1 on 2y cubed. Then it carries a square. Immediately it has a square, then it can be managed under my square root. So that's my simplification. Other methods do exist where you have to look for the LCD and so on, but that looks a little bit long. So if I go back to my formula, I'll get the integral from c to d. My c will be the smaller number, which is a 1. My d will be the bigger one. Then I'll take the square root of. I will now capture this one under my square root, which is y cubed over 2 plus 1 on 2y cubed. So that is what I get, all that square dy, then the square root will immediately take care of the square, so that becomes the integral from 1 to 2 of y cubed over 2 plus 1 on 2y cubed dy, which is now almost ready for integration. I said almost because with integration you can't leave y at the denominator except the power is 1. So we have to take the y to the middle direction also. So this takes us to integral from 1 to 2 of y cubed over 2 plus y to the power negative 3 over 2 dy. So we are now ready for integration. When you integrate, you add 1 to the power. So if you add 1 to 3, you get y to the power 4. Then you divide by 4, which makes it 2 there, to become an 8. Then if you add 1 to the power negative 3, you get y to the power negative 2. If you add 1 to negative 3, that gives you negative 2. Then you multiply by negative, you multiply the denominator by negative 2. It gives us negative 4 from 1 to 2. So if we make our power positive, so that becomes y to the power 4 over 8, then this becomes negative 1 on 4y squared from 1 to 2. So that is what we get as our integral. Then we can now substitute our limit. So if I'm substituting my limit, I start with the upper limit. I put 2 everywhere there is y. So 2 to the power 4 is 16 over 8 minus, if you put 2 there, 2 squared is 4. 4 times 4 is 16. So that is 1 over 16. Then minus, I go to the lower limit. If I put 1, where there is y, 1 to the power 4 is 1. So I get 1 over 8 minus, if I put 1 there, I get 1 over 4. Then I can go on and check what my calculator says about the answer. So 16 over 8 divided 2 minus 1 on 16. Then if I open the bracket, it's minus 1 on 8. Then 2 negatives become a positive, plus 1 on 4. So I get my answer as 33 over 16. So it's 3 over 16 units. If you are interested in this math, that is also not a problem. So 33 over 16 will give us 2,0625. 2,0625 units. For those who are interested in this math. So guys, that's our arc length for that problem. Thank you very much.